All right, we are continuing to work with rate problems. If you haven't seen part 1 of this video, you might want to. It is going to be labeled part 1. This one we're going to be dealing with 2 more problems. The first is the minimum or maximum value something gets to. Okay, and this is something we're going to do using the candidates test. In 2015, it came up in part C. I think this is the hardest part of these problems in my mind, is the amount of water in the pipe at a minimum. What's the time? We got to find it. So remember, for the candidates test, we need to look at the endpoints. So we need the amount of water at, so the amount of water at time 0 is going to be something they give us. They gave us how many cubic feet of water there were at 0. We can find the amount at t equals 8 by using the fundamental theorem of calculus. So that's going to be 30 plus the integral from 0 to 8 of the rate that it increased by, which is r of t dt, minus the rate that it decreased by. And this will give us an amount. That's the endpoints. But we also need to take into account the fundamental, the derivatives. Now, remember that we can have a local minimum or maximum when the rate of change is 0, when the derivative is 0. Well, the overall derivative is when is the rate that it's increasing by minus the rate it's decreasing by equal to 0. Because this is how much it's increasing by, this is how much it's decreasing by. When that difference is 0, we will have a local minimum or maximum. And so what we need to do is we need to solve this using a calculator. And that involves graphing r of t minus d of t. We would graph this minus this, and we would see where it's equal to 0. We would find the intersection. And at that point, we would need to find the amount. So at whatever we found for that t, we would find that amount at that time is equal to 30 plus the integral from 0 to whatever that time was that we found. So whatever that amount we found, we're going to find the y value, the amount there, by using the fundamental theorem of calculus. And one of these values has to be the minimum, and one of them has to be the maximum. And so we will be able to answer that question. The same thing came up in part D of 2018. That's funny. I didn't even... Okay, yeah. D of 2018. When is it at a minimum, right? So what we're going to do is we're going to find r of 0, or sorry, the amount of people at time 0, which it told us was 20. We're going to find the people at time 300, which is the other endpoint. And we already found that in part B, whatever that number is. And then we also need to check where is the number of people not changing. So again, whereas r of t minus 0.7 equals 0. Another way to say this is when is the rate equal to, when is the rate of increase the same as the rate of decrease, right? Because when it's increasing and decreasing by the same amount, that could be the local minimum or maximum. So again, we will find the solution to this and find that using the fundamental theorem of calculus. Okay. The last question we're going to look at is solving for a time when the amount is something. Okay, and this requires setting up a function for how much there is at any time. So we can always set up a function for the amount as 30, how much it started with, plus the integral from 0 to t of the increase. So if we add up the total amount it increased by, and we take away the total amount it decreased by, this will give us the total amount at any time t. And this is useful for a bunch of things. Sometimes it just asks for a function for the amount at any time t. But also if they ask, you know, solve for the amount when it will be 50 cubic meters of water, as it asks here. The pipe can hold 50 cubic meters of water, right? But do not solve an equation that would tell you when it will reach 50 cubic meters. Well, it's when is the total amount equal to 50. This also came up in 2018 in part D. Part C, when is the first time there are no people in the escalator? Well, we found the number of people at 300. I wish I had that answer. We're going to call it like 400 here. I don't actually know. And now we're no longer adding in people. So all we're doing is decreasing. So I'm going to put minus 0.7t. And when is that equal to, what does it ask? When are there no people in the escalator? And so we would be able to solve this equation. So again, I guess we should just do the integral from 0 to t of 0.7 dt. That would be more consistent. Again, we can set up an equation for how many people there are at any time by taking the starting amount and adding in any of the rates or subtracting any of the rates. And that'll give us the amount of people at any time t. All right. Hope this helps.